Hi, my name is Mahitha Rachmilla. I'm the team lead for Cornell Mars Rover, and I'm introducing you to this year's rover. We've been participating in the URC for 3 years, and this is going to be our 4th year at competition. And from our past experiences, I think we learned some key lessons that we tried to improve upon this year. First of all, with increasing terrain traversal challenges, we decided to go for a more robust drivetrain, including the addition of new custom 3D printed wheels. Additionally, we decided to simplify our arm from last year to make it easier to operate as well as more maneuverable while still having 6 degrees of freedom. So our electronic system this year is pretty much the same, except there's a lot more isolation and improvements to the technology so that there wouldn't be any failures while testing or at competition. Additionally, we've moved to using an Intel MUC as our onboard processor, which is better equipped to handle our processing requirements as well as more compatible with our coding techniques.
This year I worked on the board for the H-bridge motor drivers for the robotic arm and drill. This board effectively takes in two sets of signals, a PWM signal that will regulate the power for each of the motors, as well as the direction bits that regulate which direction the motor is driven in.
This year, a teammate and I were responsible for designing custom wheels and hubs for this year's rover. In past years, we used a foam rubber tire that we had to design a hub around. Because of this, the hubs that we designed were very hard to assemble and took a lot of time to manufacture. This year, we decided to simplify our design using a 3D printed wheel. This wheel is made out of a material called Ultra 9085, which is a thermal plastic that can withstand a lot of stress. This wheel has enabled us to reduce the weight of our wheel hub assembly. Our hub this year now only takes around a minute to assemble because it has 5 simple screws that attach directly to the wheel and then thus insert into the motor.
We have several significant changes to the geometry of our rockers. We've changed the shapes both to reduce mass where we're capable of doing so and to increase our performance when going down 1 meter cliffs and climbing the half-meter cliffs.
We are very confident that this design will help us in competition and will make us a competitive team at the University Rover Challenge.
So in addition to our aim to innovate and design up the rover, this year we placed a much greater emphasis on testing, particularly for the URC tasks. This year we have 4 additional sub-teams, which are smaller teams within our overall Mars Rover team, that are designed specifically for competition testing tasks. So these test teams focus on simulating the competition tasks so that we have a concrete plan as well as tested all of our components as they would have been in competition.
Test the shoulder.
Elbow.
Oh yeah. Now let's try end effector. Let's try grabbing something. Get the wand.
Woo! I'm so excited, guys.
Expelliarmus!
Oh.
It worked. I am frustrated.
Let's do it. Let's do it. Yeah.